Today will just be the same thing as yesterday, but with equilateral triangles. So you guys already know this, that equilateral triangles just means all three sides are congruent. Okay. Lateral in general does mean sides, even when we're not talking about math. Okay. So in general, if you can prove that all three sides are congruent, so that would be PQ congruent to QR, congruent to PR. Okay. If you have this, okay, then triangle PQR is equilateral. And I'm only mentioning it in this way because once we come back, we'll have the proofs that go along with this. So recall the proof blocks, there's a certain format that goes in and a certain answer that comes out of them. Okay? Now with equilateral, something we don't talk about as often is the idea that if it's equilateral, it's also equiangular. So if you have an equilateral triangle, IA, angular, equiangular. So if you have three congruent sides, that means you also have three congruent angles, equiangular. Okay. And we've known this a long time that an equilateral triangle has a 60, 60, 60 angles, but just formally given in a name. So if the sides are congruent, same thing as above, PQ congruent to QR, congruent to PR. Okay. Then angle P is congruent to angle R, is congruent to angle Q. Okay. Now this is basically the same thing as yesterday, it was just two sides. If we had two legs of the isosceles triangle congruent, then the two base angles were congruent. So this is just extending it to all three sides. Okay. Now because of that, no matter what, you always have a 60, 60, 60. Okay. Couldn't do that with isosceles triangles. You couldn't say, well, these two must be this measurement. Unless we knew the vertex, we could not calculate it. But here, definitely can. Okay. And much like yesterday, we also have its converse. So it's the same thing as above, but if the angles are congruent, then the sides are congruent. So it just depends on what information you're given. So we're just going to switch this up. Same thing here to say if angle P is congruent to angle R is congruent to angle Q. Right. Then segment PQ congruent to segment PR, congruent to segment QR. Okay. So if it's equiangular, it is also equilateral. Okay. So we can use this to solve all of these. Just know as we're going through these which theorem you're actually using. So if you're starting with angles, you're using the converse. And that's true not just for this theorem, but for all the theorems. You'll notice that every time we use the converse, you're starting off with the angles. Even back when we're doing, if two angles are, alternate angles are congruent, then the lines are parallel. That was the converse of the alternate interior angle theorem. So starting with angles, using the converse. So each one of these, you can see that are marked with the angles congruent. Where all these use the converse of the equilateral triangle theorem. And any problems with the sides marked congruent are just using the equilateral triangle theorem, just the regular one. Okay. All right, so for here, since we have all, let me make this a little bigger. Since we have all angles congruent, that means all sides are congruent. So if this one side is 7, so is this side, so is this side. So x and y both equal 7. All right, same thing over here with B. If this side is 6, so is this side, and so is this side. Okay. Now if we want to solve for x, just use the normal steps and we can solve for it and figure it out. 22, so x equals 11. Note that I did not substitute in 6 into here, but I set it equal to 6 because each of these sides is equal to 6. Okay. Same thing over here with C. This side here is 9. It's equal angular, therefore it's equilateral. All the sides are congruent as well. So if one side is 9, they're all equal to 9. So again, the equilateral triangles, you notice, is just kind of a smidge easier than what we were doing yesterday with the isosceles. There's no vertex angle is this and base angles are this. All the angles are just the same, so all the sides are the same. It makes it easier. So equal angular makes it equilateral. So one side is 10, so this side is equal to 10, and this side is equal to 10. If we want to solve, we can subtract 18 on both sides and find x is equal to -8. And recall, it's okay to have a variable equal to a negative, just not a side or an angle. So, because when we substitute -8 back in, 18 minus 8 equals positive 10. So the side ends up to be positive, so we're okay. All right, so that's that converse we just used. The next row is just using the regular theorem, finding the angles. So for equilateral, that means we're equal angular. So all 3 angles are the same. So if this is angle is 60 degrees, so is this one. Angle 2 is 60 degrees. And we can find out what x equals by subtracting 11 on both sides. That's 49. Divide both sides by 7. X equals 7. Okay, F, same idea, nothing different here, just more practice. If it's equilateral, it's equal angular. All these are congruent. Angle 2 is equal to 60. Therefore, x again will be -10. A few more. Throw in some algebra at some point. All right, so what type of triangle is G? Yeah, so be careful. Let's not just jump to conclusions that now everything's going to be equilateral. So these are all equilateral because they had the 3 marks. That's the only reason I know that. This only has 2. So this is isosceles, which means these 2 angles are congruent right here. So if this is angle 2 is equal to x plus 65, so is this one, right? So this is basically a review from yesterday. We got 2 times the base angle plus the vertex angle. So we got 2 of the x plus 65s plus the third angle, the vertex angle, which is 74. Those add up to 180. So always looking for the markings to tell you what type of triangle it is, never assuming. Okay. And once again, we'll probably end up with a negative here. Which is okay. That's perfectly fine. Now the directions aren't really clear what it's asking you to do. Is it asking us to find x, or should we find the measure of the angle? All right, so this one, probably just to be sure, let's take our negative 12, substitute it in. So 65 minus 12 would be 53. So each of these would be 53 degrees. And the nice thing about the angle problems is that you can always do a check, add all these up. If they don't equal 180, you know something's up. You can't do that with sides because you don't know what they're supposed to equal. Angles we do. Good. All right, so that's just a bit. Do a little more practice down here, just knowing the difference between the two, isosceles or equilateral. And it's just counting the markings, that's all. So really fast, we can kind of tell just by looking at the markings. That's isosceles, got two sides congruent, isosceles. Three sides congruent, equilateral. Two sides congruent. And three sides congruent. There we go. And we can find each of these measurements doing what we have been doing today and yesterday. So if across from this congruent side is 67, across from this congruent side is also 67. Across from this congruent side is angle X here, so is this. This is also angle X. We can do what we did above, 2 times the base angles plus the vertex angle is 180. So the 2 base angles by themselves will equal 80, which means each base angle is 40. All right, back to equilaterals, the ones we like because they're all equal. Hey, 60, 60, 60. This one was 40. See, this one, K, looks like across from here we have 74, so across from here is 74. And the vertex angle, this time we're finding the vertex angle. The last one, we're finding what the base angles were. Still the same idea, 2 times the base angles plus the vertex, 2 times the base angles, which are 74 each, plus the vertex, makes 180. And this is going to be 148. And 180 minus 148 would be 32 degrees. Oh, 32 degrees. And L is the same as J. Really, was just they put the 60 on the other corner, so nothing different here. Equilateral is equal angular. Those are all 60. All right. So on the back, just a few more, maybe with some algebra solving and some other angles. So once again, first look at all the markings. Know what type of triangle you're working with first. All right, so that way you know what set of rules to use. Two isosceles. Most of these are isosceles. They require a little bit more than the equilaterals. Okay, so all these must be 60. Right. You'll notice that this makes a linear pair, so these do add up to 180, so that checks out. Here we got across from this congruent side is 45, so across from this congruent side is 45. And we can calculate this, remember, by adding these two remote angles together. That was the theorem from, I think, Tuesday. Okay. Of course, we could also add these, and it's 90. And since the whole triangle is 90, this must be 90. And then x minus 90 is 90. That's another way of getting there, a little bit longer. Okay. So here, equilateral or equiangular. So this will equal these two, the sum of these two will equal this exterior angle. Basically the same diagram as we have right here, just facing the other way. So exterior angles of triangles always equal 120. We looked at that as well too before. That's 120. That's 120. If you add up all the exterior angles, 120 plus 120 plus 120, you do get 360. So the exterior angles of any polygon is always 360. Okay. Over here, same thing. Across from here we have x, so across from here we have x. So much like here, 60 plus 120 is 180. 125 plus what is 180? So we end up with 55. So that's 55. This must be 55. 110 total. All right, so to get to 180, I need 70 more. That would be a 70-degree angle. And no surprise, 55 and 70 add up to 125. So the exterior angle always adds up to the two remote interior angles. All right, last one. I think we got here x. We want to find this vertex angle. And first we'll have to find the two base angles and what these are. We can call these y, both y. And y will equal, since this is a linear pair, we know 148 plus y is 180. So y will equal 2 to get 50, 32 total. So if we got 32 and 32, what does that make the vertex angle? So same as the front, 2 times the base angles plus the vertex is 180. And we're expecting a pretty large number, right? You know, it's definitely bigger than 90 degrees just by looking at the diagram. So 180 minus 60 would be 120 minus 4 more, 116 degrees. Technically on I think all of these are actually all degrees. Yep, there we go. There we go. Okay, so just a little bit more solving. Most of the work that we just did was on the isosceles triangles, not the equilaterals. So anytime you see equilaterals in the future, including on your proofs, you're probably going to be thinking this one's just probably going to be a little bit less complicated, and that would be accurate. Okay, So you guys will go through for the rest of the class. We've got plenty of time. Okay. And do what we just did. Okay, a little bit more. Okay, do a little bit of review from earlier this week. Sum of interiors will depend on how many sides. Sum of exterior is always 360. Okay, and these are all regular. So of course that means all the sides and all the angles are congruent. If we didn't have this part right here, we could not calculate any of this. We'd have to use a protractor. But assuming everything is the same, all the sides, all the angles are the same, which is what regular means, we can calculate each one of these just by dividing how many sides there are and so on. Okay, so go ahead and use the rest of the class to finish up the previous assignments. Finish up the 3 before this, 42, 43, 44. When you have all 3, go ahead and bring them up, and I'll mark them off and put everything in areas, and then you can finish up 45.